Hello and welcome everybody to today's Fusion 360 live stream. My name is Angelo Juris and I've got my buddy Brad Tallis, as usual, being the wingman and answering questions on the chat. I'm just going to take a quick look and make sure that everything looks good on my end. Yes, it definitely looks good. Thanks, Brad, for letting me know. Today we're going to be covering drilling in Fusion 360 and everything in the drilling menu and all the options. As usual, Brad answers the questions. If there's anything in there, please let Brad know and he'll pass those questions on to me. And as they come, I'll try to answer them. And then also at the end, I'll try to come back to those and answer anything that hasn't been addressed thus far. So let me switch my screen. All right, so today what we're going to cover is drilling, everything here under this drilling menu. And it's very simple. We've got two icons there, drilling and hole recognition. Now, hole recognition, that's part of the extension. I'll talk about that in a little bit. But what we're going to cover first is just this part here, just drilling. Now, I've created some examples for you. We'll go through all of these, and I'm going to show you how to handle these guys. All right, so the very first one is very simple, is just covering drilling with point selection. So very first thing we do, let me come back to that. So we click on the icon, drill. Very first thing we do, we need to select a tool. It remembers the last tool I did, and in this file, that's what I had. So I'll keep that 1/4 inch drill. These holes are 1/4 inch diameter. You'll see I have some points here as well. So once you select your tool, we come here to geometry. And under hole mode, we've got this drop down, and you can do by selected faces, where you'll select the face of the hole, like the inside diameter of the hole. Selected points is what we're going to cover first. And so I can grab these points here like this, grab a couple of these guys here. I could also grab this circle. So I'm just adding these points here like this, clicking these guys. And the other thing that this is useful for is, let's say you have a pocket like this here, and you want to do what we call dog bone, where your end mill, let's say our end mill is a 1/4 inch diameter and our drill is a 1/4 inch diameter. And you'll see what I mean in a moment. So when you click your points, whether it's a geometry, a circle, a point, or an end point, like on these corners, you could even go out here, not that I would drill out there. And then under the heights tab, you want to expose some things here. So I've got a little UI issue on my computer here, the way I have my menu, my monitor set up. When I come over here and I click this drop down, it's bleeding off to my other screen, so I got to drag this guy up here. Bear with me. There we go. So now it exposes this. That's just the way I have my desk set up here. So then now what you do, you'll select the whole top or whole bottom, how deep do you want to go, things of that nature. So now when you come over here, you can see like the depth of the hole. And there's some things that I'm going to talk about here. Just taking a quick peek over at the chat and see if Brad said anything in there. Nope, looks good. All right. So a couple of things I want to talk about is when you select a depth on the point. Now we're going to come back to the whole faces, but I'm just talking about on the points. You could select your depth, and then you've got this option. You could break through that. So remember, I clicked the bottom of that pocket. So the tip is going to the bottom of the pocket, but if I say drill tip through the bottom, then the outer diameter of the drill will go to that depth. You could also give it a breakthrough depth. You can give it a value here. I'll just say 0.1. You also have this option for an offset here. You can give it a value there. I'm just going to keep this simple here like this. And then we're going to come over. Let's drag this guy down. I don't need to access that drop down menu anymore. And then under cycle, we've got the cycle type. And you have all these options. Drilling, that would give you a G81. Counter boring, that's also countersinking, would give you a G82 with a dwell. Chip breaking would give you a G73. Deep drilling would give you a G83, and so on. I'll just leave it as a simple G81. And now we get this. I purposely left this out because when I was in that option down here, remember there was a value there and I cleared it. So you need a value there. So that's why that failed. So always be mindful of that. Now, I was just going and clicking these corners to show you how you have options where you can click on an arc to get the center. You can click on a point and you can click on endpoints of your model. So this is just the basic one of drilling. I honestly don't really use this too often. I only use it if I'm doing something like this. And my buddy Devin in Denver, he does the same thing. Devin Dupuis, he's a rock star in Fusion. He also uses this. And it's super useful for that. You don't need to create any geometry. So that's the simple one with just using the points option. Now, what I tend to use more often is the whole faces, where you select the face of the hole. Now, I got this model, and I did a cross section there so you can see the hole. And what we're going to talk about is how to drill the hole and also give it a chamfer at the top. We're also going to talk about tool orientation. Okay, so I'm just going to go through these one by one. We're just going to start fresh. So I'll do a drill. I know that's a 1/4 inch hole. And on geometry here, I'm going to use selected faces. And I'm going to select that cylinder, the inside of that hole. Now, what happens when we click on that face? Fusion does a couple of things. It gives us a highlight. The lighter blue is the cylinder that we selected, and then the dark blue is the actual drill. And you can see the tip of the drill is going to the bottom of the hole because we selected that face of that hole. And if we come to the next tab, if we go to the Heights tab, we get exposure to some of the options that are happening automatically in Fusion. So I generally start at the bottom, and it says the bottom height is the whole bottom. And the top height is the whole top. So this is useful if you're doing anything on your modeling, and if you change things up. And let's say I change my hole depth because I told it obey the whole bottom. This will automatically update, and I can dive into that and show you. The other thing, like I talked about a moment ago, is drill tip through bottom. So watch when I click that. Now the outer diameter of the drill will go to the bottom of that hole. And again, you can give it a breakthrough amount if you wanted to, and it'll show you instantly the update there. So I'll just leave that at 0. Remember, if you just hit a delete and there's no value there, you'll get an error. So make sure you hit 0. All right, and then again on the cycle, you have these options. I'll leave it at drilling. That's pretty much all there is to it for a drill. Super simple, super easy to do. And then also what I've got here, I've got a spot drilling operation. And typically you do want to do a spot drilling operation before the drill. And let's go ahead and do that. And I'll show you what I mean. So we'll go to drilling. We'll select. We'll go to the simple hole option here. And this is the tool that I'm using. And there's just a 1/2 inch by 90 degree spot drill. Again, I'm going to select the whole face And look what happened when I selected that hole face. It took that 1/2 inch tool. So now this is a 1/4 inch diameter hole. I'm using a 1/2 inch spot drill, and I just want to spot drill the top of that hole, and I want to give it a chamfer. So remember, by default, it's coming on as a bottom. The bottom height is the whole bottom. But look what happens. I've got some options here. And again, I got that issue. Let's see, what if I make my screen full size? There we go. So now I get that. This doesn't bleed off my screen. I should have done that from the beginning. Okay. So now what I'm going to talk about is here to chamfer width and chamfer diameter. So if I tell it chamfer width, and if I tell it chamfer width of, let's say 20 thousandths, let's look at it from the front. Now that chamfer, it's going to give me a 20 thousandths chamfer. What if I leave that at 0? Now if I zoom in, you'll see the tool will come just to that edge. And I do want to break that edge just slightly. So I'll say 20 thousandths. And then on my cycle, instead of drilling a G81, I'm going to do a G82 and give it a dwell. My magic number is 0.3, a third of a second. And the reason why I give it a dwell is because I've talked about this before on other live streams. When you're drilling, imagine you're at a drill press and you're countersinking a hole, and you pull on that handle on the drill press, and it gets to the bottom, and you hold it there for a moment. You don't just come down and lift that handle back up so the spot drill goes in and out quickly. You come down and you want it to dwell there for a moment and pause as the tool spins around, a couple full revolutions. And if you think about a CNC machine, the way they work, they're always looking ahead at what the next move or command is. So on a CNC machine, it's going to come down to the depth and then retract really quickly, and it may not even it may not have a moment to pause. So that's why I recommend a G82 or a counterbore or countersinking cycle for that reason. So let me switch back over. Now, again over here, we've got that dwell for a moment, and I'm going to hit OK. And obviously, I did want to drag that up before. So I'll do the spot drill and then the drill. So then when you execute that, I got a couple of these instances. Let me get rid of these that I don't need. And so we've got this spot drill and drill. So if I simulate this guy, let me turn the stock on so you can see it. And I'll hide the model so you can see what we're looking at. So keep in mind, I've got a cross section here. And so I got a chamfer and then the hole. And we didn't even do this side over here yet. But that's basically it. Drilling in Fusion is so easy. So let's turn that model back on. Now, another thing that we had in the drill menu is if we go to drill, and let me grab my spot drill, and I'll look in this setup here, and I'll just grab that spot drill. And now on the geometry tab, if we look down here at the bottom, we have this tool orientation. So by default, the tool orientation will be based on your setup, the Z normal to that. But let's say if we have a situation where we're on a 4th axis machine or a 5th axis machine, we could now click our Z axis. I can grab this face if that's normal to the hole, or you can just grab that cylinder. And look what happens. So let me deselect that and show you again. So pay attention to the blue arrow, and that's the Z direction. And if I highlight this Z and I click that, it's going to put that Z in line with that cylinder. But you'll notice that it's flipping the wrong way. So you've got this flip axis here, or you could come in and click on the arrowhead if you like, but this checkbox will handle it for you. Now I've got my options turned on under preview where I can adjust the turn and tilt. That's going to be something I'll talk about later on. So I've got my orientation of this hole, and I don't have a whole face selected yet. So I need to highlight this, the whole face, and grab that. And remember, it's using that spot drilling operation. And again, I need to tell it to a chamfer width. And I'll give it that same value, 20 thousandths. So it breaks through. Obviously, I'm having some violation there because of the way my model is established. So I can maybe make that a little bit smaller. And I can even maybe do something like this. Just a small corner break. And then again, if I want to drill that hole, so I spot drilled it. And now if I want to drill it, I'll come here, I'll click drill. I'll grab the proper tool. Again, I could look into this setup here. I'll grab that 1/4 inch drill. And under geometry, again, now look here, check it out. I'm hovering over here and I can grab this cylinder, but I'm unable to grab this cylinder. Any ideas why? Any ideas why I can't grab that hole? I'm clicking with my mouse. I can grab this one, but I can't grab that one. And the reason is because my tool orientation, it's looking for holes in this orientation. So I need to activate tool orientation. Again, select my Z normal. I'm going to flip it so Z is pointing in the right direction. And now when I come up here, highlight this in blue, and I'll grab this cylinder. And now I've got that hole under the heights. I'll tell it drill tip through bottom and hit OK. So I did that spot drill and that drill. The other thing I could have done, guys, if I want to be lazy, I'll delete that. So I can take this one that has everything set up properly for me as far as the orientation. I can simply right mouse click. And an easy thing you can do is Command D or Control D. And now I just made a duplicate copy of that. And what I can do, I can come in here, change that tool. And let's grab, again, I'm going to scroll in here. I'm going to look for that 1/4 inch drill. And that guy is, where is it? Where did it go? Here's a drill, 1/4 inch drill. Now I got the drill. And remember, because I copied that operation, my Z normal is already established. And then the heights, instead of to a chamfer width, I'll just tell it to whole bottom. I could have also done a derived, create a derived operation, things of that nature. There's more than one way to establish and get things done to your liking. I'll turn on drill tip through bottom and hit OK. I'm not going to worry about the drill cycle. So that covers a couple of things on drilling with some orientation. Now, the benefit and the beauty of that is, let's say I've got this model and I edit that model and I come over here to this chamfer. If I look at that feature, you can see I did a chamfer with 2 distances. So one distance was a 1/4 inch, the other distance was 0.1. So what if I change this to 0.2? And now my chamfer is different. And now the hole is at a different angle. This face is a little bit longer. What happens if I come over to manufacture? My operations are dirty. They need to be regenerated when they're red like that. And I'll just hit generate. And look here. This one automatically updated because it's parametric in line with that hole. Same thing with this. So that's the beauty of using the whole faces, because when using the whole faces, it's parametric. So when you select that inner diameter, regardless of what happens to the model, the diameter or even the depth. So I could have changed those hole depths and the toolpath would automatically updated because of my parametric selections as far as the whole top and whole bottom. So I highly recommend using that. It's super helpful. Makes your life a whole lot easier. I'll take a quick look and see if there's any questions there. So it looks like my buddy Gerardo, he had a question regarding making a boring tool and using fine boring cycle. So I don't know what kind of machine you're on, if you're on a Haas machine, or a Fanuc control machine, that's going to be a G76 fine boring. And on a Haas, you can select the, let me switch to my face here. So if you've got a boring bar and the tool bores in, you don't want to wrap it out or feed out. Will obviously double the cycle time. So if you feed in and feed out, you could do that. The other thing you can do on a boring bar is as the boring bar goes in, you can stop the spindle and then it'll wrap it out. The other one that Gerardo is talking about is the G76. So what'll happen, the tool will come down, then it'll orient in line with X or Y depending on your settings, and it will shift. So then when it rapids out, it doesn't leave doesn't drag across that whole finish that you just machined. So that's good for bearings, things of that nature. If you need a really precise hole, you would use that. If I have time, I could share that towards the end. All right. So next, we talked about a simple hole. Now, I've got another option here. So this one here, we did not have a chamfer model. There was just a cylindrical hole with no chamfer. This next sample I'm going to show you, I do have a chamfer modeled in there. And so let's go ahead and create a toolpath for that. So I'll grab a drill, the drilling operation I should say, pick my tool, and if I navigate to this setup here, I can grab my spot drill, hit select. Now under geometry, what we've done so far, we've done point and we've done face. So we have been grabbing this cylinder, but if you're spot drilling, you can grab this. So that will establish the depth of the tool as well. So I selected that face, and then when I do that, again, if I look here under heights, it's looking at my whole bottom. Under cycle, I can update that to the G82 and simply hit OK. If I wanted to drill that hole, I can come here, grab that drill, taking a look at the other screen, make sure everything looks good. Chris Lee, I see Chris Lee's there. Gonna grab a drill, and under geometry, my selecting faces, I grab this. Now look what happens. We've got the depth of the hole and we got the top of the hole. So if we look here under heights, it's looking at the whole top and the whole bottom. Another thing I do like to point out here is under geometry, you can do auto merge hole segments. And what that will do, it will project that cylinder to the top of the model. So it's kind of hard to tell, but you can barely see it. So right now, it's going to start drilling at the top of the hole. If I do auto merge hole segments, it will project that cylinder to the top. So it'll start feeding from the top. And you can see you got the yellow line is the rapid, and then we've got a green line. They're actually stacked on top of each other because it's rapiding here, feeding down, and then rapiding out. So that's what you're seeing. You're seeing that yellow line. Again, under the heights, I can say drill tip through bottom, and there we have our hole. So very similar to the other one, except we selected for the chamfer, the top of that chamfer. Now, remember how I said if you go to your design, and let's modify that hole. I'll hit edit feature, right mouse click on that hole, edit the feature. And if I look here under my diameter of my countersink, if I tell it something like this, 375, now I've got a bigger chamfer. What happens when I come over to manufacture, and let me regenerate, and if I look at, this is the one that we created live, the depth automatically updated because I'd selected that cylinder, or that cone I should say. So it's parametric regardless of what happens, the tool will follow that. And I find that really useful as a machinist. Super, super useful. And also this one here, it auto projected still to the top because the top of the hole is here. And again, look what happens if I uncheck auto merge. So it'll start drilling from there. All right. So moving on, let's take a peek. Looks like Brad is handling the chat. Thank you. We got Devin in the house. Devin is 1186. Devin is a super smart guy. He's awesome at Fusion, and he's a cool guy, and he's got a pretty awesome beard as well. I could never grow a beard like that guy, but all is good. Okay, so we've covered drilling holes using points. We've done a simple hole. We've done this guy. We did it with points. And then next, we want to do a threaded hole. What happens if you have a threaded hole? So this here is a 1/4-20 threaded hole. We're going to need a spot drill. We're going to need a drill, which is a 0.201 for that recommended hole size, and then a 1/4-20 tap. All right. So I'm just going to start fresh. I can even take these guys. I've already created them. I'm going to just delete those guys. Get rid of this guy, get rid of that guy. Okay, so we've got our blank setup. Again, I'll go to drilling, select the tool, and I could look into this setup and see what tools I have there. There's nothing there because I just deleted it, right? But here, I've got them here. There's nothing in the setup yet, but it is in that document. So be mindful of that, guys, here. This will look at the document, and this will look at the setup. And remember how I was in that setup and I deleted it. There's no tools in there, but these tools are still in that document. Be mindful of that. So same thing. I'll grab the spot drill under geometry, quick and easy. I'll grab that face, verify that it's a spot drill. You can save defaults and all that. I'll get to that in a moment. Next, I'll grab a drill. And again, if I look in this document, there's my number 7 drill, which is a 201 diameter. Drag this over a little bit. Come into here. Under geometry, I'll grab that cylinder and turn on here. Drill tip through the bottom. Now, when you're drilling and tapping, let's say the threaded definition is from here to here. What I like to do is break through deeper. So you'll want to drill deeper. Now, depending on who you ask, you'll get a different answer. But me, I'll just go something like this. Go 1/4 inch deeper. Who cares on the depth? Obviously, if you need to be mindful of breaking through, things like that. But on a hole like this, I don't care. I'm just going to drill that hole deeper. And on cycle, I can tell it deep drilling. One thing you can do here under the pecking depth, you can right mouse click, you can edit your expression and modify this to whatever you like. So currently it's set at 50% of my tool diameter. If I do something like this, it will then peck 25% of my tool diameter. So there's that value. Hit OK. And then I'll hit drill again here. I'll grab now. In this document, I'm going to grab my tap, 1/4-20, and the TPI is threads per inch. Tap, grab that guy again. Grab that cylinder. I'm going to hit auto merge hole segment, and it'll project to the top. If you don't do auto merge hole segment, you could on here, instead of saying hole top, you can say model top. And you'll get the same result. Cycle, because I've selected a tap, it automatically selects that for me. So now if I highlight my these operations, I can turn them on. I'm going to select them here like that. You could see that we've got the spot drill, the drill, and then the tap. So let's simulate that. So we got our spot drill. We've got our drill, and it's pecking. Remember, 25% of my tool diameter. So it's drilling deeper than the modeled hole. And in this case, that's fine. And then we've got our tap. So that's how I generally will do a tap, is I'll drill deeper and then tap less than the hole depth. You can nerd out and do some formulas, things like that, but that's the basics of this part. Okay, next. What if I had a part like this, and I've got this table with a lot of holes, and this is going to be a 1/2-13 threaded hole. So I already went through this, I created it, but I'm just going to go ahead and delete them, get rid of those, and start from scratch. Take a quick look at the chat. Okay. So we'll come here to drilling. We will select a tool. And now this time I'm going to look in this library here. And I'm going to find a 5/8 spot drill, because that's going to be a 1/2" 13 threaded hole. So I want my spot drill to be bigger. I'll grab that spot drill. Here's my tool under geometry. I'm going to keep it selected faces. And I'm going to grab this face. And now look at this. I have to grab this face. And if I have all those faces, that would be really painful. So I'm going to deselect it, come back to this, grab that face, and then look at this next checkbox here, select same diameter. If I turn that on, it will automatically find all those holes, whether it's 5 holes or 50 holes or 500 holes. Super useful to do that. And that works on the cone of that chamfer when I selected that face, or the ID, the inside diameter of that cylinder. And we'll show that in a moment. The other thing here, you can change the ordering. So pay attention to those yellow lines. If I do order by X, then it'll start here, come down in X, and then move up in Y, come backwards, and so on and so forth. You could change the ordering in the Y direction. You could do inside to outside, and you can do optimize order, things like that, but let's keep it clean. You can do bidirectional, toggle that on or off. You can reverse the order. So what I'll do is reverse the order. So what I would do is spot drill this way, and then it ends right here. And then when I want to come back in and drill, I can then drill here by hitting reverse order. So if I was to pay attention, see the red arrow and the green arrow? So if you wanted to spot drill, drill, and tap, your table's not rapiding all over the place. So again, this is our spot drill. I don't want to spend too much time on this. Leave this as counter boring, give it a dwell. Again, we can make defaults. I'm not going to worry about that right now. So we got that one there. The alternative way is here, instead of selecting that face, I could have done a diameter range and told it the diameter of that hole, and then on the heights tab given a chamfer height. Could have changed that to chamfer height. Not going to worry about that right now. So let's come here to drilling. We'll grab the next tool, which is going to be that 421 drill. That's a tap drill size for a 1/2-13 cut tap. If it's a roll tap, it's going to be a different size. All right, we're going to grab this cylinder here. I'm going to zoom in. Grab that cylinder. I'm going to do auto merge hole segment so it projects to the top. And remember, select same diameter. It's going to grab all those holes. And again, I'll order by X. Drilling, I'm not going to worry about the cycle. You guys already got that. And remember, I want to drill tip through the bottom and then give it a breakthrough amount. And remember, like I said, you can give it a deeper value. Let's unzoom here. And you can change that and it'll automatically update. Always be careful you don't break through and drill into your table. I remember one instance, I was at a shop and they had a brand new Kurt vise, and the guy had the part sitting on the Kurt vise and he accidentally drilled through into the top, or the jaw, the solid jaw, and he took some metal stamps and stamped oil, so it was a small oil hole, which is not the case, but pretty funny story. All right, so we've got that drill. Next, we want to tap it. Again, I'll come into here. I'll select my tool. I know it's sitting here in this document. I'll grab that 1/2 inch 13 cut tap. Under geometry, I'll grab that whole face. And again, what we're doing here, we're doing things super manual, where I'm selecting, doing all these settings. And then because it's a tap as my tool, it automatically selects it as a tapping cycle. So that's one way to do a part like this. The other thing I've done is I created a drilling operation where instead of using the selected faces, I can give it a diameter range. And I know that hole is 421, so I can say something like this, point 419 to point 429. I can give it a range. It will grab all of those. And then under the heights, instead of going to the model bottom, I can give it a chamfer diameter and say go to a diameter of 0.530, because that's going to be a 1/2 inch threaded hole, and I want to make that chamfer a little bit bigger. And then I would go through, select the cycle. Okay, counterboring's good, and hit OK. And then what you can do if you did something like that where you did it by the diameter range, I already created a template for this for you guys. So I'm going to delete that. And remember all those manual selections we've done. So now I can right mouse click and create a toolpath from a template. So I've got this drill and tap 1/2 13. I'll grab that template and it'll populate, drop these tools in here. And now when I right mouse click and hit generate, it automatically found all those holes for me. There's all the drilling and there's all the tapping. So I can right mouse click here and hit simulate and go ahead and drill. So that's pretty useful if you're doing things like this that are repetitive. You could use the diameter range to automatically find things so you don't have to do any manual selections. I'll close that so we don't spend too much time on that. Holy moly, we're already 40 minutes in. Nice. Time certainly flies when we're having fun. All right, so let's see. From Ayal, are there pros and cons using model patterns versus cam patterns? Okay, so what that question is, if you have a hole, so let me delete this. And let's go ahead and just do a drilling operation. And we're starting from scratch. And I have a, let's say, a spot drill. And then I select a face here. And there's that. So the other thing you can do, you can right mouse click and you could add to pattern, even if I had all three of those toolpaths. Then I can say a linear pattern. And then I can tell it how many instances. I can tell it the distance between the two holes. And I can say there's, the number of holes. And it automatically will give me all those holes. You can kind of see those yellow out there. But you need to know the distance, the spacing in between, and then the number of holes. So I like using the select same diameter. And then if I give it an additional direction, like that way, And then I would give it the spacing. I need to flip, reverse that direction. Give it here, whoops, -2 to flip it that way. And then again, you'll have to, tell it how many instances. So you could use patterns this way, but it takes a little more manual effort to do so. It depends on what you're doing. I typically like using patterns if I'm on a rotary axis, or if it's on a tombstone on a horizontal, things of that nature. Hope that explains that. That might be more suited for another conversation on another live stream. All right. Thanks, Brad, for handling those. Okay. So the next one we have is what if you have different diameter holes? So I created this model, simple, and I have these holes here, 6 holes. The first hole is 250, second is 51, 52, 53, 4, and 255. Excuse me. So what we've been doing so far is, under the geometry, we've been doing a selected face. So if I select that face and I say select same diameter, it's not going to hit any of these other holes because they don't match. They're not the same diameter. They're 1/1000 different. And it could be, it doesn't matter what the increment is. So instead of selecting faces, I'm going to do diameter range. And it's using that, it automatically populated that for me. So you can tighten things up, or you can make things broader. I can say go all the way up to 1/2 inch, and it'll find any hole up to 1/2 inch. It will put that same drill in that hole. So it doesn't matter the size of the drill. It's simply looking for that range. So it depends on what you're trying to do. And let's say we've got a document, or we've got a mechanical drawing. And let me see. Can I put something in here? And on the tolerances, it'll be something like this. X, X, X. 3-place decimal. The tolerance equals 0.005. So if you had it something like this, your mechanical drawing says a 3-place decimal, the tolerance is 5. So I could use a 1/4 inch drill or a reamer on all of these holes, and I'd still be within tolerance. So I wouldn't need to get 6 different reamers to make it 250 all the way to 255. So using diameter range, it depends on the situation and application. You can use it to your benefit. And again, we've got our heights. I'm not going to worry about that. You guys already got that. Okay, 15 minutes to go. Time certainly flies when we're having fun. Next, what if we have a part like this? Take a quick look at the chat. All looks good. Thank you, Brad. And Devin, thanks for engaging with the users. You are certainly welcome to join any of these, and perhaps we should do a collaborative live stream sometime where we can nerd out together. So appreciate you, Devin, being on the call or answering those questions. A lot of these tips here, guys, Devin is the master of when he does his Fusion demos. Okay, so we've got this part here. If I look at it, so I got this hole. It's not sure if all of you know this, but in Fusion, if I click on any feature, so if I click on that line, it'll tell me the length of that edge. If I click on this, it'll tell me that's 12 millimeters. If I click on this circle, it'll tell me the radius is 3. And this circle here, the radius is 3. And that circle there, radius is 3. What's this counterbore? So that's 5. So it's a 10 millimeter diameter with the 6 millimeter through hole. So I've got all these holes, but they're different heights. And even this counterbore, look, the depth is different. So I'm going to show you how we can handle these guys. So I already went through this, drilled all those holes, did the counterbores, and did some more counterbores. I'm just going to go ahead and drill a new one. Drill a new hole here. I'm going to grab the drill. Let's see. Let's grab that 6 millimeter. So to clean up so I'm not looking at all of this, I'll just go to this document and I'll just grab that 6 millimeter diameter drill for the metric audience. I wanted to do something in metric. All right, under geometry, again, selected faces. If I grab that inside cylinder, what happens when I do select same diameter? It will go ahead and find every hole. And remember, the auto merge option, turn that on. And then also, we've got some of these, we're going to talk about that when I get to kind of show you how this works here. You can notice, look when I do this side view, the hole, so this is 12, remember this was 12, this is a 12 millimeter, but these holes are different depth, but it's still going to that hole. So look, remember drill tip through bottom, and you can also give it a breakthrough amount. Let's give it 1 millimeter so it breaks through. But coming back to this here, we've got these filtering options. You can say only the same hole depth. So if I check that, now look, it's only going to drill the holes that match that face that I selected. That's a 6 millimeter diameter, and that hole length is 12 millimeters. So this hole is also 12 millimeters. These holes, they're the same diameter, but the distance does not match, nor does this one or these. So Fusion's very smart to go ahead and go through these and do some selections. We also have, look at this. If I select this hole here, it's going to find they're the same depth, they're the same diameter, but I can also say only do the ones that match that same Z height. Okay, I can uncheck these, so it's just going to do everything. Occlusions, what's occlusions? So if you look at this tooltip here, if you cannot reach that hole, if there's some geometry in the way, it will automatically avoid those holes. Okay, we are quickly running out of time, guys. And one thing I wanted to highlight is, what if you had, do I have that sketch boundary? Yeah, so I have a boundary here. And when we were drilling these holes, we had this option here under containment boundary. So I turn that on by hitting it. It's blue. It's asking for some user feedback. Now you can come into here and select a sketch, but depending on some of your settings, they will grab whatever the projected geometry and it'll grab that. But so for this example, I'm just grabbing that sketch, and now it's just gonna get the holes that are contained within that sketch. Now it is all parametric, so if I come to the design side and I come to this sketch here and I edit that sketch, if I grab like this and come to here and even take this out to here, something like that. Now look, when I come to my manufacturing side, that needs to be regenerated. Now it's going to drill all those holes that are contained within that sketch. I'll turn that off so it cleans up a little bit. But super handy, super helpful. Take a quick look at the chat. All right. Next. All right, so it looks like Phil Brown is in the meeting. Cool, awesome. Thanks, Phil, for being there. Phil and Devin are masters at this kind of stuff. Okay. So I did some drilling, which we talked about live, and then we can also do some, what if we have this counter borehole? We can plunge that with an end mill. You could also come into here, and you can do a bore or circular, and I can grab that cylinder, I can do select same diameter, and it'll grab all of those. And look at the depth of those. They all vary. Got to make sure I have the right tool. 1/4 inch end mill, so that looks good. And let me give this some RPM so it's not red there. Passes here, you can give it multiple passes. You can say 2 passes at, say, 1/2 millimeter. Oops, mistyped that. And now if I hit OK, actually, one thing I like to do is lead to center, so the tool will plunge on center. And if I simulate that, and we can run that now, it's going to do each of those holes. Of course, I could play with my height so it doesn't retract so high, but then it'll obey that cylinder height. Next, one thing I did want to show you before we end is another way to do that is I could use the drill command. So I'll have that tool, and under geometry, I can tell it a range. So that counterbore was 10 millimeter diameter, so I can say 9.9 to 10.1, and it'll automatically find those as well. And then when you come into here, instead of drilling, you can do bore milling. And then here you can tell it the pitch, that's the amount it's going to step down as it spirals down. And then the diameter of that bore is 10 millimeters. Now it'll show that preview in blue like it's a drill. But if I simulate that, give it a second to think, and then we can run it, and it will now bore those holes. So you could use an end mill in your drilling operations. Super handy, super useful. Looks like we have a question from SoCal, Plymouth, and Dodge. So we need a solid model to drill holes. No, you don't need a solid model. Remember that first example I showed you is this guy under points. When I selected a drill, I can just do points. I can just start clicking and it'll give you the holes. The problem with that though is it doesn't have the associativity to a cylinder, and then you lose a parametric ability there. So then it becomes very prehistoric. You got to do a lot of, you need to tell it the height and the depth and things of that nature. So leverage the model, guys. Leverage the model that your customer gives you. Because anytime you move a hole, change the hole diameter, change the hole depth, like we did on this one here. I can even, like I said, come down here. If we go to design, if we change that hole depth and even that chamfer, so here the depth of that hole was 0.5. If I change it to 0.750, now the hole is deeper. And again, and I can change that chamfer diameter. Let's make it 0.4375. So it's a bigger chamfer now. This is why I like leveraging the model and keeping everything parametric. Whoops, I have 2 decimal points. See how it's red there? Make sure you don't fat finger it and do a typing error. So now we've got a deeper hole and a bigger chamfer. If I come here to manufacture, and if I regen, everything will update. So the spot drill updated, and then the hole depth automatically updated. So I like using it that way because it just makes my life a whole lot easier. When you're drilling, it just follows the model. So if the model's right, which it should be, then your tools will automatically follow that as long as the tool is associated with that geometry. Where as a machinist, sometimes I see a customer, they'll provide a step file, and then the modeled holes are either the minor diameter, like the size you would drill it, and other times you'll get it where the hole, so for example, on a 1/4 20, the hole would be modeled as a 1/4 inch hole. Other times I'll see it as a hole is modeled as a 0.201 drill. Well, that's fine if you're doing a cutting tap, but what if you have a roll form tap? Then that hole should be 0.228. So then me as a machinist, I like to determine the tools I'm using. I know sometimes on manufacturing drawings or mechanical drawings, you'll see spot drill with the countersink or the diameter. Sometimes the mechanical engineer will also put drill it at 0.201, such and such deep, and then tap 1/4 I don't really like that. I don't want the engineer telling me how to drill that hole because I may want to use a roll tap instead of a cutting tap. So that changes your diameter. So as a machinist, we need to be aware of those types of things and make sure we choose the right tools and strategies. We are quickly approaching time. I want to obey, keep everybody's schedules in mind and not go over too much. We do tend to go over. The last couple of times I've been trying to be mindful to end on time. It's always a privilege for me to be here, to spend some of my afternoon and day with you guys. We appreciate you as customers of Fusion. I'll take a quick look at the chat. Doesn't look like there's anything else in there. SoCal, Plymouth, and Dodge. Posse, yep, you're welcome. AL, too much lingo. Sorry, Phil Brown put some things in there. Devin, thanks guys for helping. Brad, thanks for helping. I think I covered everything. I briefly touched on templates. We didn't even go into hole recognition. Let me go back to this side. We will touch, since this is an extension, we'll have to cover that on a future live stream because that's just going to be a whole nother conversation. Looks like everything is good on the chat. Brad is handling that. Thank you, Brad. Thank you for the regulars who join us. Again, Devin, thank you for providing some of these cool tips and tricks. And, oh yeah, there was one last one. I forgot. Devin did a part. So he has this template. We got 1 minute. Yeah, we can do this. He created a template for where it handles all of these holes. All of these holes. And then there's, if you have a part like this, let's say you have a die with all of these parts. Sorry, I almost totally forgot about this one. And let me come into here and let me delete all of these operations. So if you have a part like this with all kinds of different holes, some are reamed, some are tapped, you'd have to go through these one by one and do a lot of manual work. So what Devin did, he created this guy. And so this is the master setup. I'm just going to grab all of these. Oh, I need to switch my screen. Sorry. Thanks, Brad. Okay, we got this part here. Thanks, Brad. All right, my bad, guys, my bad. I always forget to switch screens. That's part of doing these lives. I'm just a machinist here. We make mistakes. So if you got this part with all kinds of holes, I can take this template and copy all of these tools or these operations, and I can copy that. I can now paste it into this setup. And if everything is set up right, so you can see I'll expand these. There's so many toolpaths. I'm not going to go through each of these, but I can right mouse click, generate. And as long as your template is set up properly, it will go through and machine that whole part. Obviously, I didn't do any pocketing or whatnot, but you can leverage templates. And again, we'll have to cover that on a future live stream. This was provided to me by Devin. He does a lot of cool things. So I can even simulate this guy really quick just so you get an idea and to see that it did work. Now, keep in mind we have the, let me hide the stock because those pockets I didn't machine, but you can see it's going to machine that whole part. So if you have families of parts that all have the same features, just the hole locations are in different areas, you can save yourself a whole lot of time. All right, with that, we are just over the time limit. Appreciate having you guys here. and spending some of your time. Like I said, it's always a privilege for me as a machinist to be here and to share some of the things that I have experienced and talk about how and why I do things a certain way. So with that, you guys all have a great day, great afternoon, great evening, wherever you are, and be safe. And we'll see you next week. Brad will be on next week at the same time, same place, and we'll catch you next time. Take care, guys. See you next time.